Good morning, everybody. It's 9:10. I'm going to get started. Welcome to class, and welcome to this Wednesday, September 23rd. It's a special day. If you don't know, yesterday was Equinox Day, the fall Equinox Day, or it goes by September Equinox Day. This is the day where, in the Northern Hemisphere, where most of us are, I think all of us are, it's the day where the night and the day were almost equal in length. And if you didn't know, this is the beginning, the official beginning of fall. So all the days we have had so far are not fall. Sorry, we were in summer, but from today on, or yesterday on, we will be in fall. And we're going to be starting a new topic on data visualization. And because it is fall now, my warm-up question for the day is going to be tied with that topic. Not the topic we're discussing, but the topic that comes up because of it's a season. Last time I was disappointed because I asked a warm-up question and the answer was unanimous. And I had to report something that was 99% and it was not very exciting. This time I'm going to see variations. The question of the day is this. Of the 4 seasons we have, which one is your favorite? A one-word answer. Fall, spring, winter, summer. You've got one of those 4. Go ahead and tell me what your favorite season is. You don't need to explain. Some of you may like winter because you can go skiing. I don't need the answers, but I would like to get that one. There may be a couple people who may come late. So David, if you are there and if you hear me, please go ahead. It's obvious what the question is, but please can you go ahead and type up the question. Warm-up question of the day. What is your favorite season of the 4 we have in a year? So go ahead and write it. I'm going to start this, and while you type, I'm going to point one thing, and then I'm going to very briefly ask for Chris's help to take us to Blackboard. He's doing an awesome job there. He has kept his job. He may lose it sometime if I get somebody else who would be equally qualified. But Chris, get ready to, not now, but to go to, okay, but perfect. It's all right. It's all right. I think if you do that, then this is also okay. I was going to show something else, but I think this would work out. So if, I don't know if you have taken control. So Chris, go to Blackboard. This time, I want you to go to content. Okay. And stop there for a second, very quickly. So far, what you know, where there were 4 folders. We had 4 folders where we have fun stuff, right? We have lectures, assignments, resources, and tutorials. Today, I added, or some days ago, I added something called Tableau. And this is, now you can click, is a software. It is a software for data analytics that is visual analytics. The name of the company is Tableau. The name of the product is also called Tableau. And I usually ask for student license when we start the topic of data visualization, and that usually comes later in the semester. But this time, because we've moved it, which is what I will be talking when I get back to my slides, I have asked them to do early, and they have. And I have had this for a while, but I didn't want to overwhelm you. But this is the moment for you to have it. So if you go there, you will see an email response they gave me. And so I wanted you to understand it. So it begins by coding my name, and then the Tableau software academic program is what they are. So this is a commercial product. It is useful. Some of you may be aware of it. Some of you may not be. We are going to, I want you to know it. I want you to use it, but we're not going to spend a whole lot of time using it in terms of discussions. But along with visualization, I will at least point out a few things. And there may come, especially when it comes to projects, where you could make use of it. So if you follow these instructions, it will take you to a place where you would download. Our class has got a license, and so it will walk you through what you need to do. You supply your WSU email address, and then you give this code, and everything that it asks you to do, go ahead, do it. Make sure that you install, and this is something that you would enjoy for a year, and they may come back and tell you what you need to do to keep it for longer time if you need to. But as a class, and they have been good with working with me, and I've been grateful for what they offer, academically speaking, to students, but in particular with us, they have been doing a great job. So this is a resource that you have, and this is the only thing I wanted to point out today. So Chris, thank you very much. So I'm going to go back to my slide, if I can find it. Am I the one sharing now, or are you going to give me a chance to share again or something. You took over, so should I take back?
You can take it back. When you take over, there's a little button that says you can just kick the other person off. So feel free to just kick me off.
Can you kick yourself off?
I already did, yes.
Okay, so then why don't I get my slide up then? Let me see. I'm going to do this again, I guess. Here's where I was. Share.
There you go.
Okay, we're good, right? Okay. So I have told you the Tableau story, and so I'm going to get started with today's discussion on data visualization. And let me get there. Before I do that, this was the slide I wanted to bring up. You remember we saw this in week 1 when it was summer. It was not fall, sorry. So we had this, and data visualization was scheduled for November 2nd week 11, after we have had a discussion on machine learning and things like that. I changed my mind based on the observations I have seen from your survey and my own thing. Actually, it makes a lot of sense to bring it up now, and it is fun. And so you might just as well use it for your project's purposes also. And so it is moved up. That means we have the other things kind of pushed back, and so I may update the syllabus so that you have this for yourself. That's one thing I wanted to point out here. We have been doing great in terms of assignments, but there is a change. This was a little pessimistic, so we're going faster than what I thought we would do here. And so we've completed 4 major topics. What is data science, intro to R and Python, exploratory data analysis, and we've been wrangling with data. And we borrowed Monday's class to finish off on data wrangling. I have told you what you need to do during your lunch break that day. I'm sure you have walked through the rest of the material on data wrangling. And by the time you finish assignment 3, I'm sure you will have a good sense of what I try to accomplish through this one. And so we're ready to start data visualization now. And while I'm on this slide, I'll tell you what's coming up next week. We will have an overview. We'll have a couple lectures on data visualization. Today will be 1, but we'll have at least 2 more. And so that will be, we'll take a day from next week, but we will use one of the days to have an overview on machine learning. But the more important thing I want you to be looking forward to is that's the week I will be introducing project setup, the semester project setup, and the ideas I have and things like that. That will happen next week of September 28th. And then the rest of it will, for quite some time, machine learning topics that would come. All right, that was what I wanted to show you here. Data visualization is our topic today. And these slides and the content I have, you could call this one Data Visualization 101. I called, when you get the slides posted on Blackboard, I'll call it Data Visualization Part 1, because there will be some more parts that would be coming. And this one is based, and if you have seen, and if you've missed to see the slides for today so that you can follow along, I have written a little note that says, I want it to be interactive today, so I'll post it right after class, not before, like I sometimes do, so that you can take your own notes. I think this is best suited for a presentation of that kind. And so this material is based on slides and a chapter. Steven Skyna, I think that's the correct way to pronounce his last name, at Stony Brook has written a chapter on data visualization in a data science book that he has. And so these are, to give credit to him, I wanted to make it obvious that these are things that I have been inspired by, or they are adopted from his lecture material. We don't use a book, and that's good for us in some ways. And so we're writing our own book. If you follow along what is happening in the lectures and the notes and the material we have, we are kind of having our own take on this one. And every time there is a need to go somewhere else, we'll go. And so he has a book, but it is not something I would have adopted for this class. But this particular discussion on this part 1 of visualization, he has some good things to show. And so that's what I will be starting today. Okay, we're going to have this discussion, and some of you might have encountered something like this. And every time I may have a reason to suspect that you might have encountered something, I will say it so that you don't get bored. But we are going to have a couple characters today. And the first character, the first person, his name is Anscombe. He is a statistician in the 1970s or so. He had this example that is an excellent way to start when it pays off to visualize data. So he got a name for himself. It's called Anscombe's Quartet because it has got 4 things. And these 4 data sets are chosen, he designed them carefully so that they would look almost indistinguishable from one another if you were to look at them like what I'm doing right now. So you've got numbers, you've got X and Y. This is like relationship between X and Y is what we'll show you. There is one case, there is a second case, there is a third case, and there is a fourth case. In all of these 4 cases, the mean, and there are 10 numbers in each one of these, the mean, the variance, the core variance, or whatever this other one is, or the standard, yeah, the mean, the variance, correlation, and regression line, they are exactly the same. But these 4 data sets are very different. If I give you 30 seconds to look at them, maybe you may see what would stand out, but it is very, very, very difficult for someone to see how they would differ. If this was to be visualized, you will see a very drastic change, and it will be so automatic, it will be so obvious what the relationship between the things are. Lesson, it helps to plot, it helps to visualize. And that tabular data, the 4 things were impossible to see. We're humans, in case you forgot, and we operate better when we see. Most people, some people are even more driven to that, but most of us are like that. And so something that is visually there is easier to understand, but in some cases it's so crucial. It's so crucial that you will not have been able to look at the patterns in these 4 cases. So the 4 numbers that you saw, maybe the 4th one was easy because there was a repetition of 8, 8, 8, 8 everywhere. So maybe you can see it. But the other ones were really difficult to know. But now once you have them, you have that. 4 data sets with 4 or 5 different statistical measures that are exactly identical, including the regression line. But when we visualize them, they get different. So character number 1 is Anscombe. He was a statistician in the 70s, and he came up with this example. If you have been to any presentation or somebody give a keynote speech or something like that, you might have seen this one. Or if you go to Wikipedia, you may see this exact same figures. And so I wanted you to know about that. Character number 2, his name is Taft. When I was talking about exploratory data analysis, I told you a big name there, somebody who is considered a father of exploratory data analysis. There is someone called Taft, and I don't remember his first name, who is given credit for having to articulate what it means to do good visualizations. A good portion of the discussion that we will have today will actually be looking at his principles to do good visualization. You remember you did assignment 1. Assignment 1 was fun. It was about yourself. I asked you to plot your data science profile and things like that. It has got multiple purposes, that assignment. And one of the things was for you to know where your strengths are and so on, and or rather what your profile looks like. But there was also a little bit of a visualization thing there, because there was, I asked you, how do you order them? Would it look pleasant and things like that? And some of you had good takes on it. There isn't right and wrong. That's not the most important point, but there was a visualization effect to that too. So you may feel guilty when I go now through this, and what Taft teaches us about how to be good at visualization aesthetics. You might feel like, oh, I could have done better if this lecture was presented before. Don't feel guilty, but you will know the kind of mistakes people would do. So he wrote a book in the 80s, and I think he has one of the best-selling books in nonfiction category or something at the time he wrote it. And he talks about visualization and to make this, aesthetics of it and make it pleasant, but also avoid mistakes. There are 4 that I want to talk about, and I'm going to take a little bit of time to talk about each one of these, and maybe a slide or 2 on each one of them, and we'll proceed how it goes. Some of you, I know a couple of you, are in maths and stat, and so optimization is a notion that you would associate with. Computer science also has got a good portion of it. Electrical engineering got a good portion of it. Maybe all kinds of engineering. There is optimization. We want to maximize something. We want to minimize something when there are constraints and things like that. I don't think people have thought of it this way, but I'm glad Taft did. There are things that we want to optimize. There are things that we want to maximize. There are things that we want to avoid or minimize. And so the first 3 things that he has talked about here are optimization, for lack of a better word. We want to maximize data ink ratio. This is the place where you will feel guilty for some of the things you did in your own visualization for assignment 1 or elsewhere. Second, we want to minimize lie factor. You may not do it intentionally, but people do that, and we want to avoid that. And because visualization is so visual, it is important that we don't exaggerate, we don't mislead, and things like that. We want to minimize what Taft calls chart junk. Many of us have had the habit of doing it in school and things like that. And people do it routinely these days in other contexts also. We want to minimize that, and we want to use proper scales and clear labeling. Helen may come and give you some comments on assignment 2. When the time comes, she grades back and then say, oh, you forgot to label your accesses. You didn't give it a good name. That's a good practice. You probably do it all the time in a good way, but that's a reminder. So 4 things that he articulates that are considered aesthetic. Maximize data ink ratio. And when you think of it mathematically this way, it would help you. What is data ink ratio? The ratio between how much ink is used contained in the data divided by the total ink used in the graphic being what you have produced. The thing on the left does a poor job. It has got lots of things used for the graphic, 3-dimensional, and many things in it, whereas the one on the right, which is the one we advocate, would maximize. The more the ink that is used is in the data, not on the graphic, which does not help. In fact, it distracts away, and sometimes it would mislead it. And so it's a good thing to keep in mind to maximize your data ink ratio, the ratio between how much ink is used for the data, for the actual information contained in it, divided by the ink that is used in graphic. Now, you're not going to go around and measure this ink like, with some instrument or something. You know the point here. And if you were to actually go there, if you were to write software package that would try to maximize this, you could use some metrics, some ways of measuring how much ink is used. And if you work for HP or some of these laser printer producers, you may actually have a career in doing something like that. But you know the point here. So what Taft is trying to do and what I'm trying to do in the time I have. The lie factor, so we took care of one, the one that we want to minimize. This may happen unintentionally, something that we are not necessarily careful about. And the thing I want you to keep in mind is this, we use graphics on a 2-dimensional space. We've got papers, we've got screens, and that's all we have, and they have 2 dimensions. But whenever we have figures, they are rendering of something that is 3-dimensional, right? And so we have to keep in mind what dimensions mean in this case, and if we are going to associate with our graphics things that are displayed by volume or area, then the proportion is going to be important. If I take volume, for example, the thing that you see, the bottles and the prices and things like that, if I wanted to show a bottle that's twice in volume compared to another bottle, making its height twice is not going to take it. Go back to your geometry, know what a cylinder is, how your volume is calculated. So if you really wanted to show double volume, then it has to be done proportionally. Think of a pie or a circle or something like that, and one is bigger or twice the other. You don't make the area twice by doubling its size like the radius. Pi r squared is what the area is, so you'll have to proportionally make it if the area is going to be made twice. And therefore, this is a place where you could lie without knowing what, not paying attention to the dimensionality issues that are inherent because of things being displayed on a 2-dimensional space, whereas what we care about is 3-dimensional. All right. Lie factor is what he calls it. The producer of these graphics may not be intentionally lying, but they would lie if they are not careful about basic geometry. Okay, that's the point I want to make. Graphical integrity is a very important thing. Here is a place where people may be doing things intentionally. And so scales are important, and sometimes you could mislead by having to show I have at the beginning given credit to where these slides are coming from. And so the examples that you see are not my choices, but these were there and they were effective, and so I'm going to retain them. So there isn't anything that I have a particular reason to choose this example, but this was the example that was in the slide. So forget about what actually the thing is. This is a book written in the I guess 3 or 4 years, and so he was relying on material that was available in 2013 or something like that. That's what you see. For us now, it's maybe 7 years old. But the point is here, there is two things to compare, and somebody is trying to convey something. On the left, which is an actual thing displayed on a TV, you see the scale beginning, the bar, or this bar charts are starting at 34 and the last one is 42. These are percentages. And you see how drastic these two things look like. But the numbers are actually 35 and 39. And you can see them on the right, what the difference is. So there is a very big difference in the visual effect of this and what message you're trying to say. Please make sure that you have graphics that has got integrity to it. The one on the right is the right one. The way we start off where we have from 0 will make the discrepancy between this one correct and send the right thing instead of misleading. Graphical integrity, scale distortion. It can happen by negligence, but sometimes it could be intentional. There is something called aspect ratio and life factors, and this has to do with how you display something that tries to show trends. And this is about choice of scale between a vertical axis and a horizontal axis. There are 3 curves that you see here. They are talking about the same thing. Something is running from February to October, and there are some numbers. It looks like it's money because there's a dollar sign on it. They are saying the same thing if you were to read them, but they are not saying the same thing the way they are displayed here. In some cases, it looks like there is a very steep decline, so just going over the cliff. And the other one looks like, flattish. The same information, but displayed in different way. There is a rule of thumb. Aim for a 45-degree line or something like that, that is called the aspect ratio between what you have on the vertical axis and on the horizontal axis. That will be the rule of thumb, the thing that you should aim for having to display information of this kind. All right. Here is this other example where you would see about visual effects and not paying attention to dimensionality and life factor. And this is another example where I have seen many people would encounter them in their presentations, including Tufts' book. Tufts' book, by the way, the one that was written in the 80s, the book itself has got plenty of examples of good and bad. And so that way you will know when bad. This is one of the ones that is called bad. And it's trying to show you information, but in very different ways. And the thing that you would be encouraged to do, and the thing that would show you the right trends and display the right information in a compact fashion is the way that's shown on the right. And so the author of this slide, this is not my question, says, can this be the same data? They are. You'll be very, very surprised. And this is the thing that you will do when I post the slides. You will look at them one more time and look at these numbers and study them a little bit. For now, just know these things are about the same data. The information displayed on the left completely misleads you, whereas the one on the right would give you the right picture. All right. We've got a few things taken care of in the principles that Tufts has. And the third one was, or I don't remember the numbers, which one it was, but it says reduce chart junk. And I said, we have done this, all of us, especially when we were very young, when we were in school and so on. We think like we are, enhancing something by adding a lot of color. We've got lots of things and things around it. Don't do that, especially if you've taken this class and if you know a little bit about data visualization. The best story you want to tell with your data is the story told by the data, not by the things that you add on it. Anything that you add on it will distract the message, and it will only make it bad, worse than it was. And so don't do that. Extra dimensionality, the kind of thing that you did, for example, when you had a bar plot and all you really needed to show what is bar charts comparing to which one another, but then you turn it into a 3-dimensional, moved it around, and that is not going to help. Extra dimensions don't help. Uninformative coloring. People have kind of a liking for coloring. We'll spend some time, if not a whole lecture, we'll talk about colors. They're important. And sometimes they're just used for decoration. You may have your own favorite colors and so on that you just want to see them, but that's not going to help and it is going to distract. And so don't use uninformative color, and excessive figure, grids and things like that are to be avoided. He calls all of this chart junk. Another place where you might have seen an example. This, believe it or not, the thing that you see on the left is an actual data, and somebody's trying to show what data is. And I would be hard pressed to tell you if there is anything you would get out of it. It's very difficult. There is lots of things that has happened. It's three-dimensional thing that looks like the axis on the vertical axis looks like it's broken. Somebody started with something and then some interruption happened. And all really that was intended to be said with this graphics could be said in a sentence, or if it is going to be said in graphical forms, much, 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 much cleaner and better. And what it is doing now is not going to help. And to illustrate this, he uses this example of a house that looks like a duck. It is a house, if you haven't seen it clearly. And nobody would know that this is a house. I'm not sure if there is anybody who would design their house like this, but it takes away the message or the main thing that would have been for somebody to know about a house. And he uses these graphical ducks, the ones that are a house but are designed in the form of a duck. Remove cart junk. This is the place where things will get interactive. This is the place where I said I would prefer not to have these things posted so that you could play with me a little bit. First, this is a bad one. And so what we'll be spending a little bit of time now, and I'm going to go ask you to be participating, is to suggest ways to make this better. We have learned quite a lot of things from Taft's principle, things to avoid and things like that. Take a look at this one and start telling me what you would do to make this better. In other words, what would you start getting rid from this figure to make it consistent with minimizing the data ink ratio, or maximizing, I should say, remove chart junk and things like that, so that it will be a powerful, good, effective display. Okay, I'm going to go to the chat session now to see people, and I think that will be the better way to do it than to unmute yourselves and speak. So let me go there and see start. Saying something. How would you improve? Get rid of this, get rid of that type of thing. So Kobe is saying scale percentage to remove the grids and color. Okay, Cody, that's a great point. Labels, remove grid, start from 0. Background color is unnecessary. I agree, Magnus, completely. Add title, change color. Okay, these are good. Harry said labels are colors and color sets. Okay, so I have to kind of parse that, what it means. But many good suggestions are coming. Themes, remove grid, color themes. I'm going to give another 30 seconds for people to come up with things to suggest to make these good graphics. XY titles, okay, these good ones. Add color. Oh, you want add color? Okay. Okay. Come on, keep telling me anything else. I think remove grid was the one that background color, remove background color. Okay, so I think yes. Okay, yeah, that was a good suggestion. Maybe level every other month. Okay, so I think awesome, very good suggestions. And I'm going to start this gradually. So we'll take care of one thing at a time. So let's start with. Let me come to the right place here. Get rid of the grid was what everybody said. At least that is an obvious distraction and very much inconsistent with maximizing the data ink ratio. It was not displaying anything useful other than taking away our attention. So already by just taking the grid, it looks a lot better. But we can do more. Somebody suggested remove the background color. And that removal, look how it has improved. And I completely agree there. And it looks a lot better now after we do that simplification. We could do more. We could do the box that was around it was unnecessary, really. And again, the data ink ratio. And so it was, in fact, think about this one carefully for yourselves. Box is not something that you would want. Not just because you want to have powerful, but there is also something that would I don't like being boxed, and it's open up, and you've got access to everything is much better feel it has got, but the appeal of it and the the data ink ratio. So we got rid of that the box that was around it. It looks a lot better. We can do more. We can do more by having to make the reading easier and a way to break. This may not have come to your mind, but where the 5%, 10%, 15% mark could be marked on these ones, which are dark bars, by having a white line in between them. And so that would reduce some ink, and it would also make this one look better. And so now, from where we were after 4 or 5 slides and lots of removals, less is more, we got to a place where it is really much better than it was before. And we could continue doing things like that and improve it. Okay, this is my slide now. And if you have not been to your eye doctor lately, think of it as a test. It's been a couple of years since I've gone to my eye doctor, but my glasses are working fine. I'm not sure if yours are, so take a look at this one. If you can see this, you don't need to visit your eye doctor. If you have trouble reading them, then go read. So that's part one. The other part, and the more important thing, and you will come back and look at this one, is to say, what chart do I use? Chart is the word that people use usually. What kind of plots, what kind of things would I use when I want to show things? We have stumbled upon this when we were doing exploratory data analysis, but sometimes you would want to be careful, or there are multiple ways in which you can do things, and your choice of what chart, what plot to use, in addition to the cosmetic things that are like ggplot and things like that would make to enhance it, that very basic choice of what plots are using, what charts are using to display information is important. And so this is a guide. It's a nice thing to say, do I want to do this? If it is like this, I would go with this. If it is like this, I would go with this. So we've got 4 categories here. If you are wanting to show relationship between things, like you remember, you might have seen the scatter plot thing to do, for example, then you would use the scatter plots or bubble chart. I will come back to it and tell you a little bit about that bubble chart part. So that's about relationship. Took care of the one on the left. If you have distributions to show, then you would go with histograms, and you would play with them more to get to actual distributions, but that will be a good starting point. And so you've got a few different guidances. So if you have this type, you will use this type. If you have this type, you will use that type of thing. If you are looking for showing composition, and like how many percentage of the class loves fall, and so on. So I could have a little pie chart or something like that that would show me the percentage, and I will do that chat analytics today, and you will hear me. And so when you have compositions to show, there is some things that you would go, things that are static and things that change over time. So you've got something on the left when things change over time, and you can see the reason why plots are better there, because you can change trace time and see the trends. And the thing that you see on the right is static, like there's classes favorite choices. If you remember the warm-up question we had on coffee and tea, I think we were kind of half split. So this class is half coffee drinker and half tea drinker. The thing that you see on the top is about comparisons. I've got one thing to compare against another thing, and so you've got different things, and depending on what you want to do. So my goal now is not to read a chart for you like this. You can do this on your own. So know its existence, and if you visit your eye doctor or you make sure that you really are patient, then you would be able to read this on the slide, and you will use them as a guide when you start doing things on your own. But not all data is going to be graphical. There are times when we actually want to have things in tabular form. Engineers are familiar with these things. There are numbers to show and things like that, okay? And so we have to pay attention to that too. When there are times when tables have advantage over plots, there are very few. Almost always, every time you're tempted to show something in a tabular form, when you're writing a paper or your dissertation or something, think twice. And nobody likes tables. Nobody looks at numbers. Like what you saw in the beginning. So it's better to have visual ways to show them, right? But there are times when you actually care about the decimal places. There is measurement that's taken that is only visible when you actually have the numbers. And so in that case, you would want to have things in a tabular form. So here is one tabular data that talks about countries and their area and the density and the birth rate and the population and the mortality and their GDP and things like that. And there isn't really a good way to show all of this information in a visual way. So table might be our only way. But there is still, we could do some things. I want us to get to much of the material I want to finish today. So I would have liked to get your thoughts on how to make this better. Maybe let me spend, I don't know, 20, 30 seconds. Somebody can say, here's one we could do to make this one better. So there are things to improve here. So can somebody suggest something? Do you see any fault with this? And what would it could do? Align digits, nice. Rows that are alternating shape or right, that's a very good one, Tyler, to make it easier to see. Maybe I will take one more and then we'll start working on this one and try to improve. Order alphabetically, perfect, that's a very good one. Add commas to the digits, yes. Some of you know, some of you may not know or may not remember, I have lived in Norway and some European countries, when they want to say what we use like a comma, they would put, or the other way around. Whenever we want to put a decimal place, they would put a comma. So the comma that you're talking about now will be the English one. So know a little bit of culture too. There are places where things are said in a different way. Okay, so I think they've got some good suggestions and I'm going to improve this. Order the rows to invite comparisons. There were a couple of good suggestions. Order the rows to highlight importance or pairwise relationships. Write justify. Emphasize with font or colors to show importance. And avoid excessive lengths colon descriptors, which was in one of the cases, for example. And so when you do that kind of improvement, you could see all of a sudden now that table looks a lot inviting. And one of the things you want to accomplish when you do visualization is somebody to want to look at it. And once they look at it, they don't kind of get turned off. You also want it to display something that they would remember in a very quick way. And you live in a world now where there is like bombardment of things coming our way. And so whether it's a tweet you're sending out or whether you're writing a paper or something, somebody's spending 20 seconds on whatever it is that you displayed, would they get something out of it? This is not something I could get something within 20 seconds, but I could get very quickly. There is something around China, for example, that has got a very large number that would jump right out at me and things like that, right? So all of the suggestions you have made, probably even more you can come up with, would improve this tabular presentation. All right, that eye chart, the thing that was making sure that your site is good, is now going to be unpacked a little bit. So there are times when you want to show that you would do line charts. And these slides will have a few things on them that I'm not going to, sitting here and read them for you. You will read them, but there are a few things that you want to remind yourselves. And when you see something quick like this, you will know them. One of the things you want to do is when you have things that you want to show trends, like for example, the one you see on the right, what is it called? Bottom corner, the south east. Yeah, I'm saying it right. You have the data points and then you've got the trend. Make sure that you do both. And sometimes it's easier to forget to do the original ones in a way to forget them and things like that. And when you have discrete values, usually it's not right to connect them. A very good example, I do lots of things in high performance computing, and so we write papers and so on. People would, and I read papers too, so they would show me, the run times for things, right? And I have this algorithm, I run it like this, and I change it this and that, and so here are the points that came, and so you plot. And usually people are kind of careless, and so they would show a continuous line. What you really have is, I have a measurement, a runtime for a particular combination of parameters, and there was one point, and there was another thing, and there was another point, and there was another, and there was. So to connect them to show the trend is fine. But when you have a solid line, and especially you don't point this one out, what you really mean is between those discrete points, whatever you have, you just join by a line, is a value is what you're saying, which is not right. You didn't measure it, you didn't get that one. And so make sure that you make those type of things explicit and avoid having to be misunderstood. But showing trends is important, and therefore you connect them. And when you have both the trend and the data point, you show both of them. Scatter plots, you have done them before. When we did exploratory data analysis, we used them. These are useful to show when there are values that are relationships, and so you want to plot one against another. And this is used for multivariate data. When you have things like that, this is slides. When I post them, I'm going to probably post the original ones, but the PDFs ones will not have some things like what you are trying to say here. But I am making a point with these ones. But I think visually, when you look at them, you should be able to see what you are trying to avoid. So the thing on the right or on the left has got a poorer way to display information, even though it's just about things that are scatter plots. The one on the right, by having to choose that resolution better, you see the tendency of this clearer. So if I can, I'm going to kind of have a note on the side when I post this one. But for today, what you will see, the PDF will not have things other than what I just told you now. Heat maps are important. You will encounter them. You probably have used them. They are effective in showing things that are better shown by having to show how they would have looked like if it was to be thought of it as a heat. R has got, and many other tools, in fact, have ways for you to display things that are shown with the help of colors in heat maps, and they show you things a little bit in a more informative way. So it's not something that you probably need a whole lot of lectures, but heat maps are good to remember and have something to work with. This is a place where I want to tell you about bubble. I don't remember exactly what they're, bubble charts they're called. And this one has come before, and I, as a footnote, talked about it in passing. You've got two things to show. 2 points, vertical axis that shows something, and the horizontal axis that shows another thing, and we've got a point that corresponds to what value it has got on the vertical axis and what value it has got on the horizontal axis, right? So there is a data point. But let's say that point that you have is of size. It is going to have some quantity. And so you want to show that too. So I have another combination of points, but the number I have for it is bigger or smaller, and I want to display this. Bubble charts are an excellent way to do that, because you can use these bubbles, the size of the bubbles, when you do the geometry right, when they're doubled, so you double the area, not the radius or the diameter, then you can now display something that would have taken you 3 dimensions in 2 dimensions. So there was a vertical value, a horizontal X value and Y value, and that coordinate had a quantity to it, and you wanted to display that information. And so by having to choose the size of the bubble to signify that quantity, that amount, now you have used alternative. Now you can add color to them, and so these points now, when they have one color would mean one thing, when they have another color would mean another thing. This particular chart that you see has got a lot of information. It's coming from a company called Gapminder, and it still exists. And this one actually is a data visualization for how countries are in terms of health and income. And so what you see on the vertical axis is about health, and what you see on the horizontal axis is money, GDP in particular. And so what you see here is countries, and their geographical location is indicated with colors, and the size, that core point where there is this much of this country has got this much money, and this is the the health that corresponds to it, is shown by the size of the bubble. So I've got 5 minutes, and this will be probably a good place to stop, and we'll come back to it. So somebody who is very, very good at typing, I'm going to ask for help now. You see a link there, and I don't want to play this one. I have learned from music playing on Zoom that it doesn't come out close, but this is a video that I want everybody to watch. It will take us 5 minutes. So somebody very, very fast, breathe, let's me call on you. Type up this one on the chat so that everybody gets to the link. So it's called www.gapminder.org. and then videos / 200 years that changed the world. And this is a BBC thing. So somebody, I want to type so that when you click on it, you would get there. I'm going to go there and yeah, perfect. Or somebody has typed it up already, or some smart way to get this one. So I'm going to go there and watch. Everyone will watch and will come back in 5 minutes. I'm going to watch myself. And if you're not allowed to have more than 5 minutes, the video will take only 5 minutes. Mute yourselves so that you don't disturb others. I will mute myself. I will stop sharing and then come back in a second. All right. I hope everybody finished. And if you haven't, some 30 seconds or so of the video is left. You can watch it afterwards. I can tell you more about Hans Rosling sometime later. There is a full production of this that will be worth watching, and I'll probably mention that another time too. He has passed away, but the Gapminder, the company, is there. So let me conclude here. And so you see the point I was trying to make, and I don't want to make it any worse after hearing him speak in a very compelling way. And so visualization is important. We're going to continue. We'll have to stop here now because it has become 10 and you'll have to go to class, but bear with me for another 30 seconds so I can tell you what's going to happen next lecture. Like we did last time, I have an invited lecture for this Friday, and this will be a person who does geographic information systems for visualization, an important topic for us. And I want to have that discussion that has got to do with working with data so that you get to a place where you visualize it on a map in a good way, in an interactive way. Tableau has got some functionality with it. R has got some functionality, but this speaker is going to make something that is done his own. He's a collaborator of mine. I will introduce him and he will have the time. I very much encourage you to attend and also try to use that one, just like Stephanie's presentation was, to generate an idea for a project. And that's the reason I want to have it here this week, so that I can make use of it if necessary on the week that would come when I talk about projects. So we will have at least 2 more. I will post these slides. There are some left, but I will still have them there. You can go through them, but I will pick up on some of them the next time we pick up this topic. I wish I had time for more to talk about them, but I think this was the best we could do for the time we had today. So let me let you go. I want to remind you, if you haven't submitted assignment 3, do it today. It's the deadline, so that you don't wrangle anymore. So we will visualize. Wrangling is over. We want to visualize. So take care, and I will see you on Friday, where the speaker will be here.